Okay, so I'd like you to have a go at doing this question to start off with, and you can put your answer into the sheet that I've created, the Google Forms, just to answer this question. So hopefully you'll to find the vertical component of the velocity, and it's multiple choice. It also says write 20 meters per second at an angle of 60 degrees in vector notation, and write the forces of gravity in vector form. Just think what way the gravity is going. Okay, so we're going to look at projectiles today, and there's a couple of assumptions that we end up making. One is that a projectile is a particle. It's not being powered, so it means there's no sort of extra forces being involved, and the air has no effect on the motion, so it's not going to get slowed down by air resistance. An example of this is like, as it sort of says here, about kicking a football. The only thing that will act on that football, if we ignore sort of the air resistance, is the weight coming down on the ball. Therefore, the only thing that's going to be bringing the ball back down is the weight. We say that this is sort of acting only under the influence of gravity, would be classed as a projectile. So since it acts vertically down, then you can see that there'll be no horizontal component of acceleration, which means we can pretty much say that the acceleration is going to be 0 in the horizontal, and it's going to be negative g in the y direction. And obviously gravity being 9.8 is what we assume within maths. In vector form, we can write it as 0 and negative 9.8. And if we know the initial velocity of the ball, then we can use our Suvat equations. And these are the two Suvat equations that will be associated with projectiles. We've also got to be very careful that where the origin actually is, especially if we're using s equals ut plus half at squared. If the ball is standing a bit higher, then we're going to have to add in plus so at the ut plus half at squared part of the equation. So here's an example. A ball is kicked with the velocity given by u is equal to 6.4 meters per second, and find the velocity and displacement after 0.5 seconds. So with this, we could be using that v is equal to u plus at, and what I should have said is that each time you can pause this and try and go ahead yourself and see if you can answer it, then look back at what the solutions are. So if we're taking v is equal to 6.4 plus 0, negative 0.8, because that is acceleration, and 0.5 being the time. We can multiply this through 6 plus nothing and 4 minus 4.9, and we get our answer of 6 and negative 0.9 meters per second. It's asking for velocity, so we can just leave our answer as this column vector because it's given both the magnitude and the direction when it's left in this component form. Obviously, if you're wanting to work out the speed, you'd have to use Pythagoras and square and take the square root, and you'd probably have to then also work out the angle that it creates. For our position, we've got 6.4 is our u, our initial speed, times by the 0.5 seconds, plus the half of negative 9.8 and 0.5 squared. Now obviously the way I'm writing this is in column vectors, but you could write this out by separating. Actually, further on I'll sort of show you that actually it's maybe worth separating them into horizontal and vertical components just for ease of the way that you end up setting out your working. Multiply that through, we get our position is 3 meters in the x direction and 0.775 meters in the y direction. So as I sort of just mentioned briefly there, it's quite important normally to separate them into the different components. So we talk about the x component and the y component, and that can be done for u, v, and we end up using the subscripts x and y just to say whether it's in the x direction or the y direction. So if we look at our two equations, we will notice that horizontally there's no acceleration, because remember we said that the gravity would be 0 and negative 9.8. That means that the initial speed will just equal the final speed in the horizontal direction. It will not be slowed down at all. It will still, if you move something at a horizontal 5 meters per second, it'll continue to have 5 meters per second as a projectile. In the x direction, it ends up being ut. For vertically, acceleration is minus g. Again, we can either just switch the formula to vy equals uy minus gt, or we can leave in without the negative and leave it as a plus, but I think generally you probably see it's easier just to make it a negative. So again, just main points horizontally, Vx is equal to Ux, and the horizontal component never changes. And there's an example where it's just getting shown through on the graph. So the horizontal speed has just stayed the same. I'll just show that again. Just staying the same each of the time. Vertically, whatever speed it ends up getting moved at, it'll end up being slowed down by gravity as it goes up. And it'll end up getting to 0 at the maximum height, which is an important part of projectiles, and then it'll become more negative, and again that will increase the speed as it drops back down towards Earth. So it's getting slower, and then it's going back down and speeding up again as it comes back down. So here's another example. A ball is kicked from level ground with a velocity u is equal to 5.6, so again 3 is in the x direction, 5.6 is in the y. Ball is intercepting its way down at 0.7 meters above the ground. It's telling us to model it as a particle, so we're ignoring air resistance, and we're assuming it's not being projected and it's not got any power in it. The time taken to reach point P and the speed and direction of travel at P. So again, it's about writing down what you know. Drawing little graphs will become important, and just labeling up what you know. So we're putting in 5.6 in the y, in the x direction we've got 3, and we're trying to get up until it reaches the height of 0.7. That's where it's getting intercepted or caught. So it's looking for the time to reach point P. So we've got v is equal to u plus at, and again we can create some equations from them in the horizontal and in the vertical. So again, remembering that the a is 0 in this one, so it cancels itself out. In this one, we've got negative gravity as being the acceleration, is the only acceleration that we're sort of putting on that. We can also use the s equals ut plus half at squared, and we can split this into x. So again, we're going to call this x, and that's just basically if you take from the origin, we've got our x coming along here, and that's the distance it's moving. Initial speed of x, which is in this case would be 3, and the time, well, we're not sure, so that's another equation. And in the y direction, we've got the initial speed in the y times by the time, take away a half gt squared. So we can class that as equation 3 and 4. So plugging in the information that we've got, we know that in the y, it's gone 0.7, and it's equal to 5.6, which is the u, initial speed, time, minus a half gt squared. Now remember, g is actually gravity, so it's 9.8, so we can just plug that in. Removing the 0.7 to the other side, you can see that we're starting to form a quadratic equation. I've just multiplied everything by 10, and then we can divide through everything by 0.7, as you kind of get the same sort of idea. We're looking at the 7 times table. You could just put the initial one straight into your calculator, and it'll be able to solve it to give you that the time is equal to 1/7 or t equals 1. Now you'll notice that there is 2 times. That should make sense to you because there'll be 2 times that this height will be at 0.7. There'll be a time here, which is 1/7, or the later on time, which is 1. So you will need to interpret results quite a bit whenever you're dealing with projectiles and make the correct call into what the time would be. We also need to find the speed and direction at P. So again, we've got our equations that we can split into our horizontal and our vertical component. And when we're looking at the speed, we've got the Vx is equal to 3. So because our initial speed is 3, our final speed is going to be 3. Again, sometimes you may want to do, when you're doing the speed, you could just go into column vectors, and maybe later on I'll show an example where I just keep it all in column vectors with the last 2. And Vy is 5.6 minus 9.8 times by 1. So we end up getting Vy being minus 4.2. So I could create a little drawing to show that we've got 3 going in the x and minus 4.2, and this is going to be the resultant if we're wanting to work out the speed. And in this case it's the speed that it's wanting. If I left it as velocity, I would just leave it as a column vector 3 minus 4.2, and that would be me finished. But it's also wanting the speed and direction, so it's wanting to work it out within Pythagoras. So we're going to end up having to work out the speed by squaring, taking the square root. We get 5.16. And to work out the angle, it's opposite over adjacent, so we get an angle of 54.5. So to summarise what we need to be doing, the projectiles, draw a diagram showing the given information. The questions will ask you to find the value at a particular point, and then basically make sure that you draw a diagram to decide if you know something about a special point. Write down the vector equations, and you may decide that you're wanting to split them into the horizontal and vertical component, or you may want to decide to work in column vector. That's your choice. Select the equation and fill in any unknown quantities. If they're still unknown, then you may have to use simultaneous equations. You may have to use what basically is parametric equations, but you may have not come into that within the pure teacher yet. Remember that you will be given v equals u plus at and s equals ut plus half at squared in your formula book. You'll just need to know to be able to switch them. Okay, with the horizontal, acceleration is 0, and in the vertical, acceleration is equal to negative gravity. It's up to you when you're subbing in, but quite often it's easier to do this to do this later rather than sooner when you're putting it in. So just leaving it as g is probably the better way of dealing with this. Sometimes also in the question they might end up telling you that gravity is 10. That's just to make things a little bit easier as well as to answer things. If it was written in horizontal, the equation of the suvat, we could write them out like this for our v in x and v in y. There's our initial speed in the x and the y. There's the acceleration, 0 in g. Notice I've already taken the negative away because it's normally u8 plus at. So I've just taken that negative out, t. And for our position, remember r is what's known as the position, where we've got the x direction and the y direction. Initial speed, again we've got the acceleration there. You can see that kind of cancels out within the top line. Okay, so another example. A ball is kicked from level ground with velocity of 20 meters per second and an angle of 24 to the horizontal. Find the maximum height reached. So again, we're looking at creating a drawing. Again, obviously these wouldn't be drawn out for you, so it'd be a case of you creating your own drawing and annotating them as best as you can. So we've got 20 meters per second at an angle of 24, and we're trying to work out the maximum height. So as was mentioned before, the height, at maximum height, the speed has to be 0. So we're going to use that fact that at that point there, the speed, the velocity is going to end up being 0 in the y direction. So if we pop in our equations, it's now just a case of selecting the right ones. Again, get into the habit of splitting them into your x component and your y component unless you're wanting to work in column vectors. Again, your choice. So this is an example where we're probably going to have to end up using almost what would be known as parametric equations, but you can't just sort of solve for one and then take that answer and sub it into the second one, and almost like a simultaneous equation type of solving. But technically what you're doing is parametric equations. So basically it's then a case of just subbing in. So we've got our uy take away gt, although the problem that we've got here is that we don't know our y component of our initial speed. We've got 20 meters per second, 24. This comes back to what was in the starter task, where we can either think about v sine, so if it's the vertical, it's in the y direction, we're going to do sine 20 sine 24. If it's in the horizontal, it ends up being 20 cos 24. So putting that bit in, so in the vertical it's 20 sine 24 over g, and we get our time of 0.83. We can then use that time of 0.83 in order to work out the maximum height. Again, just subbing it into our equation to get 11.79. Okay, so there's two more questions. I'm going to stop the video at this point, and then what you can do if you watch the second video, I'll go through this one, but in the second video I'll do it as column vectors just to show you the different way of doing it that way. Okay.